Today we are doing a tutorial for PyGame. We are getting into creating a grid for a Sudoku type game. So let's just jump right in. Okay, so here we are on the Atom. This totally blank project. We can run it. Okay, doesn't do anything. So let's go ahead and let's start writing some PyGame code. So first of all, we're going to import sys, and we're going to import PyGame as PG. We're doing that just because importing PyGame as PG is it makes it less to type. So we're going to start with pg.init. That just initializes Python or PyGame. We're going to set screen size equal to 750 by 750. I just want like a square grid to work with. This is kind of arbitrary. So screen, we're going to set the display mode. Oops. There we go. Cool. All right. Got notes over here on the other screen. All right, so the next thing we're gonna wanna do is we're gonna wanna set up a game loop. So we're going to say def game loop. And then we're going to say while true game loop. Okay, so in our game loop, we are going to do just a couple simple things. First of all, we are going to have an event loop thing. So for event and pg.event.get. And this is just event handling, nothing too exciting. If event.type equals pg.quit sys.exit. So this is stuff that originally I pulled just out of like the PyGame tutorial. Let's go ahead and run it and see if that works for us. All right, so we've got just a PyGame window here. And if we hit escape, or if we hit this little exit thing, boom, we're good. Okay, so let's get to drawing. Now, the first thing that we're gonna do with drawing is I'm going to create another thing here called draw background. And we're going to call that in our game loop. Okay. See if this works. Oops, doesn't like something. Oh, I don't have it. So you need some actual code in there because Python. Okay. Yeah, we're gonna just output things a million times. So this is looping, by the way. As you can tell, the reason it has high every time, because basically what happens is we've got our game loop. So approximately 60 times a second or whatever our frame rate is, it's going to loop. And so it's going to try and redraw the background and all that stuff. So one other bit that we do want to add here is we want to have pg.display.flip, which again, I pulled from like a tutorial, and I'm pretty sure it just flips the buffers from the memory buffer into the main display buffer. So let's actually do some drawing now. So first thing we're going to do is we're going to delete these, and we're going to do screen fill pg color white. So this is just going to give us a white background. There we go. Cool. So one quick thing of note, pg.color, this gives you a list of all kinds of colors with simple names to use. So instead of having to look up color codes, this is a really quick and easy way to get to those. All right, so let's keep moving. Now, what we want to do is we want to, like, thinking through like, okay, you draw like a rectangle, I mean, basically a square. And so we're going to do pg.drawRect, and to the screen, And then we are going to say PG color. We're just going to keep the simple black and white. And then PG. So we're going to do like a margin of like 15 on each side. So, okay, so it's like 15, comma 15. So that, I think that's the XY coordinate. And then we got to give it a width. Oops, did that wrong. PG.rect. So 15, comma 15. So PG rect, PyGame rect. You can look up all of these things, but it's basically it's a rectangle data structure. So okay, so we've got a screen size of 750, 750. So if you have a margin of 15 on each side, so that's actually 30. So what you want is 720 by 720 here. Okay, so that gives us the coordinates for drawing the rectangle. The other thing that we want to do is we want to give it a width. So let's give it a width of like 10. And let's see how that actually looks. Oops, does not like something. Oh, it doesn't like the color. Color has to be capitalized for the object. All right, cool. So we got this oversized black rectangle on the outside. That's cool. We like that. Moving on. Now, the next step is we're going to do a little iteration here. So we're going to say I equals 1, and then I being our iterator. And then what we will do is we will say, well, so what we have to do is we have to draw like 9 lines across to actually, I mean, technically it's 8 lines, but we have to draw lines every so many pixels, both vertically and horizontally to create our grid. So what we're going to want to do is we're going to want an iterator that is going to actually iterate through these things in a fairly sane way. So if you think about it, 720 divided by 9, that's 80. So what we'll do is we will say, while I times 80 is less than 720, which actually then should give us, when it gets to 9, so that last one, it's not actually going to draw, or at least it shouldn't. So that's what we want. It's slightly more efficient. And what we're going to do is we're going to say pg.draw line to the screen, and then pg color black again. And then we're going to use a vector 2. So we're going to say PG, and we are going to, because basically you have to give it 2 coordinates to draw the line between, right? So the first one is going to be I, so we got an XY coordinate, right? So we're going to say I times 80. So that gives us an X coordinate that's moving by that. And then we have to account for the margin. So we'll say plus 15. And then the X value there is going to be 15, or the Y value is going to be 15. And then we do another one of those. So that gives us our first coordinate. So like, that's going to give us like 80, comma 15, 160, comma 15, etc. So it's going to give us those ones that go across. And then we have to do the Y version of that. So basically it's the same deal where it's like PG vector 2. And then the X coordinates should stay the same, and the Y's should be basically 735, like 750 minus 15, right? So we can do the same, I times 80 plus 15, comma 15, and that's on our vector 2. And then we want it to have, I don't know, we'll say a line width of 5. See how that works. Let's see if that actually gave us what we wanted. Invalid syntax. Okay, so I probably missed a parentheses here. So, okay, let's check them. That one's fine. That one's fine. That one is not fine. Okay, I think that was the one. Oh, something broke. Oh, there's the mistake. All right. So the mistake I made is that should be 735. So it was actually working correctly. It's just that it didn't have any length. There we go. All right. So cool. We all make mistakes, myself included. Now let's copy this line of code and do the same deal, but we're going to kind of flip them around. So what we actually want is the XY coordinates to swap. So in this case, it'll be 15 comma that business, and then 735 comma that, and then delete those. Cool. Look at that. We have a sweet looking grid. Now, one thing about Sudoku that is interesting is that really you're talking about 9 sort of boxes of 9. And what you're really looking at is these should be like this line, and this line should be wider. So, what we might want to do is we might want to add a line width. So, okay, we'll say line width equals 5. So then we'll replace that. Make sure that's working. Cool, same deal. All right, now let's use kind of a Python ternary kind of approach where say line width equals 5 if our iterator is mod 3 is greater than 0. So basically if it's not divisible by 3, then the line width is 5. Else, let's make the line width 10. So what this should do is every third iteration, it should actually have a wider line width. And that's exactly what it does. So now what we have is something that looks a lot more like a traditional Sudoku grid, because you actually have a scenario where every third line, it is shaded in extra. Cool. We are making progress. Next thing let's do is let's draw numbers. And drawing numbers does not have to be super hard. So let's make that happen. Okay, so we are going to do another deal. Okay. Let's say row. Okay. Now let's run it to make sure we've got no obvious bugs. Great. So in thinking about drawing numbers, what we want to do first is we want to actually have a grid of numbers backing our drawing. So the first thing we're going to do is we're going to create a number grid. And what it is it's going to be an array of arrays. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And add a comma. And then we are going to copy this. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9. All right, we have our 9x9 grid. And this is just to give us a grid of numbers to work with. And the goal here is to display that grid of numbers. So let's make those numbers show up in the background. Now, first thing we want to do, okay. So we have 9 rows. So we'll say while row is less than 9, and we're going to start the index at 0, row plus equals 1. That way we don't make the same iteration mistake. Now, the next thing we're going to do is we are going to have column. So column equals 0. And then while col is less than 9, col plus equals 1. So what this will do for us is it will give us a structure that allows us to draw each row and draw each column. So it's going to select a row and then it's going to select the columns. So that gives us a way to iterate through our 9x9 number grid. So inside of this little bit of the while loop is where our actual drawing is going to happen. So we are going to say output equals, and this is just our text output, number grid row call. And just for fun, we will print string str output. So what this is going to do is it is going to print our output to the console. Again, not something we would do all the time, but we are just verifying that it's doing that. Cool. So that is printing out and iterating through. But we don't want to print them out to the console. We want to print it out to the screen. So how do we do that in PyGame? Well, what we do is we're going to say number text equals, all right, we have to, let's see, font. All right. We have to actually load in a font as well. I forgot to do that earlier because we didn't need it yet. So font equals pg.font. So we're going to grab the sys font. And we're going to use font size 80. That seems to work pretty well with this little demo. You can always play with these things. So I didn't, when I was prepping for this tutorial, I certainly played around with these different sizes until I found the one that looked better. So let's do that. Okay, so we have to do a font.render. And then we want to render the string output. So we'll comment out that line and eventually delete it. Okay. I forget what that true is for. I could look at the PyGame docs and show you, but I don't remember. And then pg.color black. So what that does is it will render to basically end text becomes a surface in PyGame parlance, I believe. And it basically, so that's like a little display rectangle in memory somewhere. And it's going to render that text onto it and generate you a new one. Now what we have to do is we have to blit that to the screen, which is basically copy that memory onto the screen. So we're going to say screen.blit in text, and then we have to tell it where we're going to blit it to. So again, very similarly to how we did some of the drawing of the lines, but we're going to have to do a couple different things here. So we're going to say, so we're thinking about the X value. So we have to think about the column for that row. Col times 80. So again, this is very similar to what we did up here. And then the Y value, so we could say row times 80. And then that, we'll see what that gets us. Now, I'm pretty sure that's not going to get us exactly what we want. And I'll tell you why here in a second. Haha. So as you can see, it is actually drawing these numbers right on the things. And what we need to do is we need to actually, instead of drawing it in these positions next to the lines, we need to offset the whole thing. How do we do that? Well, there are a couple different ways. So what we'll do first is we will add an offset. So we will say, actually we use the same offset over and over again. So offset, I will say like 40, sure. That's about the middle. Oops, we actually have to add that. So we will add offset to those. Run it again. Okay, that's pretty darn close, but it again feels a little off. Like if you look at it, there's a little too much vertical padding here. I don't know if there's too much horizontal padding. It does look like there is a little bit much of that. So let's make offset a little bit less, say like 37, maybe 35. Okay, now it seems to have moved too far to the left, but the vertical looks pretty good. No, the vertical is a little bit too much too. Okay, so what I'm gonna do here is let's leave the offset at 35 and we go back here and we say, okay, it looks like we're too much on the vertical. So let's pull that back a little bit. So let's say offset -3. And then if we look at on the horizontal, it looks like this is too much. So we need some extra on the X side. So let's actually increase the offset there by 4. Actually, let's do it 3 and 3, kind of in opposite directions. Hey, that's pretty good. Again, being a little bit particular here, it looks like we can move the X over to the right a little bit more, and it looks like we can move the Y down maybe a pixel. So offset -2. No, we want it -2, I think. And then we want that over one more. So 4. Okay, I think the verticals are looking pretty darn good. The X's are very close. And again, some of this comes down to the kerning of the numbers as well. Like if you notice 1 and 2, I think kerning is the right word. 1 seems like it's over by just a smidge, but the other ones look pretty good. So, I mean, we could call it there. Let's adjust the X's just by 1 more. See if that's any good. Okay, that seems, you know what, we'll call that good. Now, just to verify one other thing, if we go ahead and change these numbers to like, 7, 1. Yep, so you can see that they're all cool until there. So we have drawn a grid in PyGame that is exactly what we want. So this is not obviously a full Sudoku game, but this gives you the foundation to actually start working through a Sudoku game. So that's the end of the tutorial. Thanks for watching and have an awesome day.